Hey there, geometry. We are going to jump into 11.2 today, proving similar triangles. So I'm going to give an example of each one. Do your best to try a couple of the homework problems. I mostly want you to focus on problems 1 through 6. The other ones are going to be challenge problems this week. So take some notes, follow along, and then let's jump right in. So the first thing we do when we're proving triangles to be similar is basically we're saying, hey, if triangles are similar, then all of their sides are in the same proportion. So if this triangle ABC is 2 times larger, the scale factor is 2. That means whatever XY is going to be half of AB, and AB is going to be twice that of XY, right? And that has to be true for all 3 sides. So in order to prove a triangle similar, one, it either has to be said, hey, this is a similar triangle, or these are similar triangles, or we can prove them in a couple of ways. There are 3 ways we're going to look at. The first way is if we have an angle similarity postulate, is what this is called. If there are 2 angles in a triangle that are equal to other 2 angles in another triangle, that also means that this third angle has to be the same because every triangle has a total of 180 degrees, right? So if angle B is congruent to angle Y and angle X is congruent to angle A, we know that all of the angles in both of these triangles are similar to, well, they're congruent, which means the triangles are similar. So that would mean whatever scale factor, like I said, if our scale factor, which we call K, is 1/2, right? That would make this half the size of the larger one. Or if our scale factor came the other way, we could say that the scale factor would be 2. I would multiply by 2 to get to the larger one, or I would multiply by 1/2 to get to the smaller one. You always multiply with scale factor. You're never dividing. You say, I'm dividing by 2. You're multiplying by 1/2. Now, if you want to do the math as dividing by 2, that's exactly the same thing, but we're not going to list it that way. Okay, so if you can prove any 2 angles, or if they're given that way. Now, quick reminder, it's been a while. If I have vertical angles, those are the opposite here. Those vertical angles are congruent to each other. Okay, don't forget that. If you had intersecting angles that made 90 degrees, if this one here is a 90-degree angle, well then vertical angle says that one is also, but I know that these 2 have to be adding up to, supplementary, adding up to 180. So really all of these are 90 degrees. Okay, 2 quick tips just to look out for. But step 1, if you can prove 2 angles are congruent, then you can prove the triangles to be similar. Next one, this is a side similarity theorem. If I can prove all 3 sides to be in the same proportionality, okay, so if I multiply by 1/2 to get from here to here, then I also multiply by 1/2 from here to here, etc. For all 3 sides, if you multiply by the same scale factor, or K, then you can prove the triangles to be similar. It has to be true for all 3 sides. So let's look at this a little bit more in depth. AB here, if I have this side AB, and in ratio, whatever I take that and I divide it by this, right, division, I'm going to get my scale factor. Well, whatever that scale factor is, if it's the same as what happens when I start on this big triangle and I go to the little triangle for the longest side. If I divide those and I get the same value or the same scale factor, and if I take AC and I divide it by XY, sorry, what are those letters? XZ, then I should have the same scale factor, and I then could prove all sides to be in the same ratio, and so therefore these triangles are similar. So I would say that triangle ABC can be proven similar, and that's how we use this kind of like about, right? Triangle XYZ. Okay. Now, if 2 of them have the same, like if AB divided by XY is equal to 1/2, and BC divided by YZ is equal to 1/2, but AC divided by XZ over here, if that's like a third, these triangles are not similar. It's all or nothing for this guy. All right. the last way that we could prove triangles to be similar is the side angle side similarity theorem. If two sides of a triangle are proportional to the other two sides and the included angles are congruent, so that means the angle between the two, then we can say the triangles are similar. So this is already kind of drawn on a little bit here, but if I have, let me find the same color, that might make it a little bit easier. If I take CB and I divide it by ZY, I should have some scale factor. If I only have two sides that are given to have the same scale factor, right? So like this guy here. Okay, sorry, I didn't realize this paused recording. I don't even know where it picked up or stopped. I tried to figure that out and I couldn't. So I'm sorry, this is going to feel choppy. And I'm probably not going to teach it well again since I just did it and I can't remember what I said and didn't say. So I'm going to back up. I'm so sorry. A third way to prove triangles to be similar is side angle side, which I think I probably told you, which means I have to have two sides that are in the same ratio, so the same scale factor. I had that green one. Let's say I took CB and I multiplied it by a half, and I got to ZY, and let's say I took AB and I multiplied it by a half to get to XY. If those have the same scale factor, if they're both half smaller in your smile triangle, that's not quite enough information to prove the triangle is congruent. Because if you're only using sides, you have to have all three. Do you remember? We just talked about that. So if I don't have any dimensions for that third side, I can't use side, side, side. You have to have all three. And so if I don't have all three, but I have the angle in between, not this angle up here, not this angle over here, it has to be the interior angle, or the angle that falls between the two. I guess it's called an included angle or an interior angle. They're all interior. The included angle, if it falls between those two, it's the angle that touches both of the sides that you have the same scale factor for. If those are equal to each other, 30 degrees here and 30 degrees here, well then you can prove that those triangles are similar. And we would write it this way. Triangle ABC is similar to this little tilde mark, triangle XYZ. Okay, so let's try a couple. Your goal tonight is just to be able to identify which type of proof you would use, or which theorem or postulate you would use. So one is a postulate, two are theorems. We don't need to get into why. Do you use angle, angle, side, 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 or side, angle, side? There are three different ones we could choose. And if one of those is true, we can then prove that the triangles are similar. If not, then we can't say they're similar. That's all your goal is tonight. If you do some of the challenge work, it'll pull back a little bit of what we did before. And honors guys, you are going to need to find a couple pieces of those bits of information. You're going to need to set up a proportionality. If I were you, honors guys, you need to draw a picture. You just need to. There's some pictures drawn there. Look at the triangles, see if they're similar. If they are, go back to what you've done before. If they're similar triangles, pick out which sides they are, figure out what that scale factor is. And I know that not going into too much depth for that, you're going to need to try those. Please reach out if you need some help. I want to see if you can take what we're learning here and apply it to a real life situation that's more difficult. So that's why you're in honors. So you have to try that one. Okay, so then my goal is for Wednesday for y'all to just work on a worksheet. There's just 10 problems. It's just like this, what we've done. Do not turn that in the bin on Fridays or the weekend because we're going to finish it up on the Monday after that, okay? We're going to finish it up, and I'm going to have a video so that you can go over it with me. We're going to slow down. This section is so critical to geometry that we're going to kind of focus on it a little bit longer than we have in the other home time for the schooling at home, okay? So slow down the pace. Try to make it a little easier as you're getting ready for summer, right? Aren't we all so ready for that? Okay, I'm going to draw a couple triangles here. If it will let me. See if my pen will draw. There we go. Okay, imagine that these triangles look better than they do here. Okay. We'll call this guy A, B, C. And call him X, Y, Z. And I'm going to give you some information. I'm going to tell you that angle A is equal or congruent to angle X. And I'm also going to tell you that angle C is congruent to angle Z. Are these triangles similar? Well, think about it. We had angle, angle, two angles. If you have two angles that are congruent, then you have triangles that are similar. We had if all sides are following the same proportion or the same K value, then the triangles can be proven similar. And if we have two sides and their angle that falls between them, right? The included angle and two sides, we can also say they're similar. So does this example I gave you fit any one of those categories? I hope you said yes. This is true. We can say that triangle ABC is congruent to triangle XYZ. Why? Because of the angle, I guess this is angle postulate. This is the one that's a postulate. I'm okay if you just write this. Okay, that's all you need. You don't need to write it all out. Okay, there's our proof. Don't you like that kind of a proof? Okay, let's try another one. I'm going to give you two more triangles here. Here are my triangles. Are these congruent? Well, I don't have any angles, so I can't use angle postulate, and I also can't use side theorem because I don't have any angles. So the only one I could look at here would be side. Do I have the side lengths of all three? All three sides? Yeah, I sure do. So hey, side, right? Well, no, they have to be in the same proportion. So to go from these corresponding sides, to go from 6 to 13, I'd have to multiply by the same value. To go from, another color, to go from 4 to 8, I'd have to multiply by the same value. And to go from, there's my color, 5 to get to 10, I'd have to multiply by the same value. So here, from 5 to 10, I multiply by 2. From 4 to 8, hey, multiply by 2, this must be it. From 6 times 2, does that give me 13? So these are not congruent triangles. Now, what would I do to make these congruent triangles if I could change something? If this were let's zoom in here a little bit. If this were a 2, then I could have congruent triangles because everything is multiplied by the same scale factor, 2. So in this case, this would be, forget about that part, this would be triangle, I should have named this, we'll just call them the same letters. Triangle ABC is going to be similar to triangle XYZ because, why? What's my postulate or my theorem? Good, because of the side similarity theorem. And this is all you need for the proof. You do need to make this statement and the proof, so 2 parts. Okay, last example. Okay, I have 2 triangles here, and there's looks a little bit different than what we've had before. Let's call this A. Let's call this point here B, C, D, and E. And I want to know, is my smaller triangle here that's colored in white, is this triangle congruent to this bigger triangle? Okay, one's just kind of sitting on top of the other. So I'm trying to say, is triangle A, B, E, is this similar to triangle A, C, D? Is this true? Well, let's see. Goodness, well, I don't have all side lengths, right? So I could rule out side. I am missing this side length here and this side length here. So there's no way it could be side. I don't really have very many angles here. Now, I say very many because I do actually have one. There are no numbers here. However, because this is the same angle as itself, I know that angle A is going to be congruent to angle A because it is itself, all right? So I actually have one angle, which means I can't have angle postulate. I don't have 2 angles. So I am down to just one choice, side, angle, side. Let's see if this is true. So here's one of my sides. and here's my other side. Now I'm going to kind of redraw some of these triangles. If you are stuck, I would highly suggest redrawing a smaller and a larger triangle when they're stuck together like that. It's helpful to see them separate. So here's my smaller white triangle, and I had dimensions of 4 and 6, and I know that this angle is congruent to this angle over here. Now, on my yellow triangle, I don't have just a 2, right? I don't have, this side isn't 2, it's actually this part plus this part, the line addition postulate, if you recall. So this is 4 and then and 2 more, so just 6. And down here, this is 6 and 3 more, so it's 9. Okay, so let's figure this out. What is my scale factor here? To get from 4 to 6, I have to multiply by some value of k. I should say like this. All right, so I need to, my value of k here is 4, my original over my new. My value of k here is 6 over 9. Original over new. So, is this true? Now I could simplify this fraction 4/6. I could say this is 2/3, and I could say this is 2/3. So what I'm really doing is I'm multiplying by 2/3. To get the, I should be going the other way. It's not original over new. I'm sorry. This gets bigger. You'd have to multiply it by 3/2, by 1.5, right? My arrow facing the wrong direction. Your original should go in the denominator. Just kind of switch that here. So we're just going to say, like, you really can do it either way. So I just want to point that out. You just need to change the direction of your arrow. So then we clear this up a little bit. I apologize. So to get from 4 to 6, what do I multiply to get? So I would have to put 6 over 4, and I get 3/2, or I could multiply 4 by 1.5, and I would get to 6. If I took 6 times my value of k, if I took 6 times 1.5, I also get to 9. So what I know are that this set of sides that correspond are in proportion to each other, and I have one angle that is between the two that is equal to itself. So yes, these two triangles are congruent. They're not congruent, they're similar. So what I need to do is list it this way, and then I just give my reason, side, angle, side, similarity theorem. Okay, so those are the two pieces of information that you would need there. And there we go. I want you to try those homework problems. Like I said, we'll have a worksheet, and I hope that you guys have a good rest of your week.